Very good afternoon, everyone. I am Dr. Hima Bindu from the Department of Mechanical Engineering, and I'll be dealing with the robotics subject. And my today's topic is about the actuators. Right? So, in actuators, we have different types of actuators, in which today we will be studying about the pneumatic actuator. So what do we mean by the word actuator? What exactly the actuator means? Right? That is, generally in robotics, the movement of the robot will be done with the help of the manipulator, with the help of the links and joints. Right? So any robot or any particular human, if he is having the muscle, but there are no joints, or there is no, the movement of the human can be done with the help of the joints, right? So, in the same way, the robot movement also will be done with the help of the actuator, right? Any particular robot, when it requires a movement to be done, that particular movement of the robot will be done with the help of the actuator, right? That is, the robot without an actuator is nothing but a dead skeleton, right? A robot without an actuator is nothing but a dead skeleton, which we can use it as a showpiece only, whereas it cannot be used in any of the factories or any industry. So, the devices which provide the actual motive force for the robot joints is known as the actuator. That is a device which is providing motion to the robot joint, right? That particular motivator force is called as the actuator. Now, the actuator is used to give the power to accelerate or even to de-accelerate the links and to carry the load. And that is, in order to carry any particular load from one place to the other, the robot requires some amount of power. So that will be done with the help of the actuator. That is, it is used to make the things easy, right? This particular actuator is used to make the things easy and more reliable, to be used in the manufacturing sectors, or to be used in the in any particular education sector or any particular hospital sectors, etc. So the actuator consists of the power supply, the amplifier which provides power, a servo motor, and a transmission system. Right? The actuator the normal general actuator consists of a power supply, the amplifier which is used to provide the power, the servo motor, and a transmitter system. So here the actuator, how the actuator actually works, let us see. Right? So generally we will be having the power supply. Right? From this particular power supply, the primary power is being sent into the power amplifier. Right? With the help of the power supply, the primary power is being sent into the amplifier, where to this particular amplifier, the control power from there will be an input control power from usually from the electricity, right? That is usually with the help of the electric source, there will be an input power supplied to the power amplifier, and also there will be a primary source of the power being supplied to the amplifier. Now here in the amplifier, both these particular power sources get combined and produce the input power to the motor, whether it is a motor or it is a servo motor. So depending upon the type of the actuator, the input power is being sent to the motor or the hydraulic actuator or a pneumatic actuator, right? So from there, the power from the motor, that is the power from this particular motor, is being sent to the transmitter, where the transmitter is used to convert the energy into the mechanical power, right? The transmitter is used to convert the energy into the mechanical energy, that is mechanical power. Now, from all these particular three sources, that is from the power amplifier, from the motor servo motor, or from the transmission, there will be some losses, right? So that particular losses are being called as PDA, the power loss from the amplifier, the power loss from the servo motor, or the power loss from the transmitter is being sent out for the conversion performed by the amplifier, motor and the transmitter, right? So initially any particular actuator works with the help of the power source. That is, initially the power from the power source, that is the primary power, is being sent into the power amplifier, and the input power from the with the help of the current is also being sent into the power amplifier, and here from which the overall power is being sent with the help of the PA to the servo motor, and from there the power from the motor is being sent into the transmitter, where the energy, electrical energy, is being converted into the mechanical energy, and the power losses will be dissipated from all these particular sources, right? So that are being termed as PDA, that is power being dissipated from amplifier, power dissipated from the motor, and the power dissipated from the transmitter, right? So any particular actuator have certain characteristics, right? The actuator will be having certain characteristics based on which it will be working. So what are those characteristics and how it is being used to the actuator? Let us see. So initially the load. Load is important, where the torque is used to overcome the inertia, right? The actuator is used to enable the load. It is used to control the speed, the accuracy, resolution, repeatability, reliability, power consumption, energy supply, and its weight. So these are few of the characteristics based on which the actuator will be working. That is, normal actuator will be working. So next, coming on to the types of actuator. As I've told you earlier, we have three types of actuators. That is the pneumatic actuator, hydraulic actuator, and the electric actuator. So all these particular three actuators have some variation in its working, right? All these particular three actuators will be working on different variables. That is, when we come across the pneumatic actuator, this particular pneumatic actuator, the source of the actuator, it will be the air, right? The source of this actuator will be air. Whereas when you come across the hydraulic actuator, the source of actuator is some particular fluid. Whereas when you come across the electric actuator, the source of this particular actuator is the motor, right? So these actuators will be working on these particular principles. That is, the pneumatic actuator is used to compress the air. This particular actuator compresses the air and gives the movement of the piston within the cylinder, where this particular actuator will be placed at the joints of the robot, and when the air is getting compressed in the cylinder, the piston movement will be done, and accordingly there will be a motion analysis being done on the robot. That is, with the help of this particular pneumatic actuator, the robot starts moving, right? In the same way, here for the hydraulic actuator, as I've told you, the source is the fluid. So here in this particular type of the actuator, we will be using fluid inside the cylinder, and as the fluid gets compressed, the piston movement will be done within the hydraulic cylinder, and there will be a movement in the robot's manipulator, right? Whereas in the electric driven actuators, there will directly be a motor, whether it is a servo motor or whether it is an electromechanical motor. It will be placed in the it will be placed at the joint of the manipulator, and accordingly this particular accordingly the robot will be working. That is, in order to utilize the energy of the pneumatic energy, which is used to provide the compression and transfer it into the mechanical energy by means of the piston, as I've told you, right? The the energy is getting transformed into mechanical energy with the help of the compression of the piston, with the help of the piston movement being done in the robot manipulator, right? Again here, with the help of the pumps, right? Here in the pneumatic actuator, what is happening? Piston is being compressed, whereas in the hydraulic, with the help of the pumps, the energy is being converted into the mechanical energy, right? Whereas in the electrical actuator, what is happening? We are using the electromechanical devices which it is using is electrically controlled with the help of the gears, right? In the electrical actuator, the electromechanical device is allowing the movement through the electrically controlled system of the gear. Clear? So these are the three types of the actuators which we are having, that is pneumatic actuator, hydraulic and electric. All these particular three actuators will be working on its own principle, right? Now, as I've told you, the movement of the, for example, we have a robot being placed here, right? We have a robot being placed here. Now, this particular robot has to move from one position to the other position. So, here at the leg joints and here at the hand joints, the actuators will be placed so that the hand of the robot will do one action, and the legs of the robot will be doing another action, right? So this particular actions will be carried with the help of the actuators, right? So next, moving on to the difference between the pneumatic and hydraulic actuator. Generally, the pneumatic actuator will be, as I've told you, it will be working on the fluid. The hydraulic actuator is working on the fluid, and the pneumatic actuator will be working on the compressed air, right? So when we are comparing both this hydraulic and pneumatic, the pneumatic will be working on the fluid, whereas the hydraulic will be working on the air. Whereas this particular pneumatic actuator generally operates at 100 IB per inch 2, and whereas the hydraulic will be working at an operational speed of 1000 to 3000, right? And here generally the fluid whatever we used will be oil. In the hydraulic actuator, the fluid whatever we use will generally be pressurized oil, right? And this particular pneumatic actuator is again divided into two types, that is linear and rotary actuator. Generally, we call the linear actuator as cylindrical and the rotary actuator as a motor device, right? So, this particular pneumatic actuator is again divided into two types, that is linear and the rotary actuator. So, here this is the figure of the linear actuator. So, as you can see, this is the cylinder inside which we have the piston being placed, right? This is the piston which is being placed, right? And this is the cylinder. Inside the cylinder, we have the arrangement of the piston being placed, and this is the fluid port, right? For example, if it is a hydraulic, there will be a flow of the fluid from this port, and if it is a pneumatic, there will be flow of the air from this particular port into the cylinder. Now, as air is entering into the cylinder, and when it starts compressing, there will be movement of this particular piston in the forward and the backward direction, right? That is the simplest power device which could be used to actuate the linear joint by the movement of the piston is called as a linear actuator. So generally we calculate it with the formula V of t is equal to F of t by A, where V is nothing but the velocity of the piston is equal to the force by the area of the piston, right? Or we also can write it as the force is equal to pressure of the fluid into the area of the piston. So generally we calculate the velocity or the force of this particular piston in this with the help of this formula. So there are two relations of particular interest which can be discussed with the help of this particular actuator, that is the velocity of the actuator with respect to the input power and the force of the actuator with respect to the input power, as I have told you. So when you need to calculate the movement of the fluid, it can be done with the help of the velocity or it with the help of the force. So when we are considering velocity, it has been calculated by force by area, and when we are considering the force, it has been calculated with the help of the pressure into area. Clear? So next, moving on to the rotary actuator. What happens? How is this particular rotary actuator working? So generally, this particular rotary actuator, as I've told you, is like a motor. That is, it is a cylindrical wave where the compression of the air will be done with the help of the vanes, right? Where the compression of the air will be done with the help of this particular vanes here, right? So this is the cylinder. This is the shaft which has been placed within the cylinder, and we have the vanes being placed where this is the H is the height of this particular vanes and R is the radius of the shaft, outer radius of the shaft, and R, so small r is the inner radius. As I've told you, outer radius and inner radius, and H is nothing but the thickness of the vane. That is, what is the thickness of this particular vane? It has been determined by H. So here, when you are coming across the rotary actuator, this particular rotary actuator generally works based upon the angular velocity and the torque. Right? The rotary actuator generally works with the help of the angular velocity and the torque. Whereas in the linear actuator system, we have come across force and the velocity. Right? So here, when we are coming across the rotary actuator, we will be coming across the angular velocity and the torque. So how is the calculation part being done when we are using the rotary actuator? Is the angular velocity is equal to 2 into force by that of the outer radius minus inner radius into the thickness of the vane. So based on this particular formula, we will be calculating the angular velocities for the rotary actuator of the robo. Now, what are the advantages of using this particular type of the robo? That is, what are the advantages when we are using pneumatic actuator in the robo? Generally, when we come across the pneumatic actuator, it is simple in design, right? And the working of this particular pneumatic actuator is at a higher speed, and it generates high power and is also cost effective. So when we have these particular forms of the advantages, it can mostly be used in more of the factories and industries to reduce the cost. Right? That is, this particular type of the actuator is relatively simple in design with very few moving parts, which consists of very few moving parts. So this actuator is also very simple and it is maintenance free. It doesn't give much of the trouble, and it reduces the downtime and operational cost. So that is the reason we tell it is simple in design, because it is not giving high maintenance. Its installation is easy. It doesn't give much troubleshoot. It reduces the time, that is the working time, and the operational cost is also less. So that is one of the advantage of using the pneumatic actuator. And when coming to the speed, this particular type of the actuator has a rapid motion due to the air compressibility of the air. There will be a rapid movement of the air within the actuator, due to which the pneumatic actuator works at a higher speed, right? Where time reduction, the time will be reduced. That is, there will be a quick movement in the robo, right? And it also gives some stability, making them suitable for the quick movements such as picking and placing operations are sorting. Generally, in order to pick and place the objects from one place to the other, or for sorting out the operations, we require higher speed. That is, we require the robot to be working at a higher speed. So, one of the advantage of the pneumatic actuator is the high speed. Next, coming to the high power to the weight ratio. As we all know, this particular type of the pneumatic actuator generally signifies force relative to their size and weight. So this is also one of the advantage, and generally it is used for clamping, lifting, pushing and pulling the heavy loads. Due to its higher power, it is used for lifting, it is used for pushing the heavy loads. Next, cost effective. As it is simple in design, simple in construction, and there is no much maintenance, and installation is also very easy, it is more cost effective. It is less expensive compared to the other type of the actuators. Whereas coming across its safety, it is very safe. That is, using this particular pneumatic actuator, it is inherently safe for the air, because the air whatever we are using is non-toxic. So when it is non-toxic, it is generally flammable, and when it is non-flammable, there is a least risk of the humans being if there is any leakage problem, or if there is any sort of leakage problem of the oil, what happens? There will be some risk. Right, so since we are using air in this particular type of the actuator, and the air whatever we are using will be non-toxic, due to which it is non-flammable, and there will be a minimal risk of leakage compared to that of the hydraulic fluid. Right, so this is one of the advantage of the pneumatic actuator, that is inherent safety. When coming to the clean operations, here this particular type of the clean operations means, since we are not using any sort of oil, or since we are not using any sort of fluid, it doesn't require much cleaning to be done, right? Because it is the air which is being compressed in the actuator. This particular air, whatever is being sucked inside the cylinder, when it is expelled out, it doesn't require any sort of cleaning operations to be done. So when we come across oil or grease, we require more cleaning operation to be done. So this is also one of the advantage of the pneumatic actuator. Next, moving on to the flexible control. What do we mean by flexible control? What is it actually? That is, by adjusting the pressure levels, flow rates and valve position, it is more flexible to be used. That is, it is not, since the design is not complex, it is flexible to be used in any operating conditions. Right? The pneumatic actuator is more flexible to be used in any sort of the operating conditions. Next, coming to the next advantage is versatility. What do we mean by versatility? That is, it has a wide range of application across various industries. That is, the pneumatic actuators are used in n number of factors, n number of industries. That is the reason it is versatile in nature, and the types and the sizes and configurations whatever we are using have different tasks, due to which it comes under the versatile advantage. Next, coming to the durability. Durability means what? That is, depending upon the temperature, humidity, dust and vibrations also, this particular type of the pneumatic actuator will be capable of withstanding. right? In higher temperatures, high humidity, dust or vibrations or any particular harsh environment also the pneumatic actuator will be able to work, that is, will be able to withstand. Next, it is eco-friendly. Since it is air which we are using, it is generally eco-friendly. That is, additionally, advancement in the pneumatic, this particular type of the actuator is one of the added advantage to the robot. Right. Next, coming to the limitations. What are the limitations for using this pneumatic actuator in robots? That is, first is limited precision. Second one is compressor deficiency and limited control options. What do we mean by limited precision? Here, in this particular type of the actuator, one of the disadvantage in application is requiring the precision position and the control. That is, here the pneumatic actuators may lack the precision, right? That is, this particular type of pneumatic actuator, when it is lacking the precision, it comes under the limited precision addition. Whereas when we come across the compressor dependency, this particular type of the actuator, since it is compressing the air, which means that it is dependent on the compressor system. We need to compress the air. That is, it is dependent on the compressor system. So this is also an added complexity to the overall system. Right. Next, coming to the limited control option. Here it is limited only to certain options. Whereas in the electrical actuator or the servo motor, it can be used in any particular control system. What are the disadvantages? We will be having, whether we take a hydraulic or a pneumatic, we will be, when it come across the pneumatic, there will be air leakage. When we come across the hydraulic, we will be having the fluid leakage. Right? That is due to a small port which may occur inside the actuator. So that is common. So that is one of the disadvantage. Compressed air requirement, that is, we require a compressor to compress the air. So it is dependent on that. That is one of the disadvantage. Limited precision, as I've told you, and it gives a heavy noise. When the robo is working, it gives a heavy noise. And what are the applications where this particular type of the pneumatic actuator generally can be used? That is in material handling, assembly lines, packaging and medical rooms. In these particular applications, we can use this particular type of the pneumatic actuator. That is material handling means it is nothing but picking the object and placing it some particular point. That is with the help of the end effectors, that is mechanical gripper or any particular type of vacuum gripper, right? The material handling will be done. Whereas coming to the assembly line, that is for screwing, welding or for painting purpose, generally we use the pneumatic type of the robot. And for packing, that is for filling, sealing and labeling, we use pneumatic type of the actuator. And for in the medical robot, in the medical environment, for generally for surgeries or any particular medical opticals, we use this particular type of the robot. So generally, these are the applications of the pneumatic robot. So coming to the maintenance and safety, what are the required safeties which we have to follow? Generally, we need to check the leakages, wear and damage. Then we have to see its lubrication, that is whether it is properly lubricated or not. Next, coming to the pressure regulation, that is we need to maintain appropriate pressure levels to prevent, if the pressure is increasing, what happens? Gradually, it will get damaged, the robo will get damaged. So, we have to check the pressure regulation, we have to check whether it is properly lubricated, and if there are any leakages, wear and damage, we need to maintain it. And we need to train the robo for safety handling and maintenance procedures. So, these are the safety precautions which we need to follow. Next, coming to the control system for the pneumatic actuator. What are the different control systems? That is, we have 4 different types of the control systems for this pneumatic actuator. That is manual control, solenoid valve control, proportional valves and feedback system. So, depending upon these particular control systems also, robot operation will be done when we are using a pneumatic actuator. That is, generally in order to control the valve, it should be automated system. For the automated system, we need to have an electrically controlled valve. Whereas when we come for more precision operation, we provide variable control, right? For more precision operation, we provide the variable control systems. In that way, we need to support this particular control systems for the pneumatic operator. So, in today's class, we have discussed about the use of the pneumatic actuator, where it is being used, what are its applications, what are its advantages, disadvantages, what is maintenance and safety, what are its various control systems to be used, what are the types of the pneumatic actuator, that is linear and the rotary type of the actuator. All that we have studied in today's class. Hope you have understood. And next session, we will be discussing about the hydraulic actuator. Right? Thank you.
Like, share and subscribe. Hit the bell icon for more updates.